Hi everyone, and thanks for coming to the session. I'm Martin, I'm a fourth year PhD student from Saarland University and the FKI in Germany. But before I start with today's talk, I would like to thank my co-authors André, Simon, Tony, and Antonio for their time and contributions to this work. So in recent years, we have seen many hand-based illusion techniques that serve the purpose of, for example, simulating haptic properties of virtual objects, such as pseudohaptic weight. Here, Seibert and colleagues simulate the sensations of a heavier cube only by visually slowing down users' real-world movements of the cube. Illusions have also been used to enlarge the interaction space, for example by extending users' arms, allowing them to interact with distant objects. So these techniques work by offsetting the position of the user's virtual hand from the position of their real hand upon interaction. So in this example, a user's virtual hand is gradually being offset horizontally during a reaching movement. And this allows the user to interact with three virtual bunnies while touching the same physical proxy bunny in the real world. To a certain extent, these visual manipulations can remain unnoticeable to humans due to the visual dominance phenomenon. However, ultimately, the question arises how much offset between the location of the real and the location of the virtual hand remains unnoticeable to users. Because if the introduced offsets become too large, they disrupt the immersive nature of the VR experience. Therefore, researchers investigated so-called detection thresholds, studying how much offset during hand redirection remains unnoticeable to humans. And there exist many studies that looked at this. For example, Zenner and Krüger report estimates for detection thresholds not just in the horizontal, but also in the vertical and depth axis, while other studies looked at the effects of movement direction or hand representation on the detection thresholds. Yet, current detection thresholds have only been studied with mid-air floating hands that are disconnected from a user's body. However, a more prominent and complete avatar provides more visual cue anchoring and may therefore reduce the unnoticeable redirection threshold. As a result, it is unclear whether the large body of illusion techniques and the perceptual limits can be applied when moving to more complete avatars. And this is quite important because there's a growing interest in full body avatars made available by more advanced body tracking of consumer VR systems. Therefore, we define the four avatar completeness levels hand, hand plus arm, full body, and full body texture that are commonly used in VR systems. And we study how they affect the sense of embodiment felt towards an avatar, and whether avatars with higher embodiment decrease the hand redirection threshold. To investigate this, we designed a two-phase within subjects experiment comparing our four avatar completeness levels. In phase 1, we assessed the sense of embodiment felt towards an avatar. Phase 2, we conducted a threshold experiment using the psychophysical two-iterable force choice method. And as a side note, in case of the full body texture avatar, participants could freely choose one of the two options. We recruited 24 participants from our institution and the local university. We took measurements of our participants and calibrated the avatar to them in terms of their height, lower and upper arm, as well as hand length. Participants remained seated throughout the experiment and wore 5 HTC Vive position tracker attached to their hand, feet, and head. The avatar poses were computed using inverse kinematics through the Final IK Unity asset. To assess the sense of embodiment, participants were instructed to replicate 10 body poses using their body, hands, and feet for a total of 2 minutes, which is sufficient to create the illusion of body ownership. This example video shows how this looked like for 2 body poses and the 4 avatar completeness levels. In addition, we used a virtual mirror in front of the participants so that they could see their virtual body to promote sensory responses. After participants successfully replicated the 2 body poses, we assessed the level of embodiment, which we called OALA, by using a relevant subset of Gonzalez, Franco, and Peck's avatar embodiment questionnaire. Afterwards, participants proceeded with the avatar from phase 1 to phase 2 of the experiment. Here we exposed them to horizontal hand redirection of different magnitudes using a 2-interval force choice method. Participants performed 2 consecutive reaching movements, one without hand redirection and one with hand redirection of different magnitudes. And we asked them whether the 2 movements felt the same. And they had to respond either with yes or no. And once the interleaved staircase procedure converged, we obtained the detection threshold for this avatar completeness level. And phase 1 and phase 2 were repeated 4 times. That means for each avatar completeness level. So next I'm going to talk about our results. So first we analyzed the level of embodiment felt towards an avatar using a non-parametric Friedman test and Bayesian statistics. Overall, we found that increasing the level of avatar completeness significantly increased the sense of embodiment. And this is in line with previous results in the field, but was a prerequisite to ensure that our renderings elevate the sense of embodiment. Thus, we can confirm our research hypothesis 1. Next, we examined the detection threshold and found strong evidence for the absence of an effect. The Bayesian analysis suggested that it's about 7 times more likely that there is no difference between the avatar completeness levels in terms of the detection thresholds. To further examine this, we plotted the relationship between embodiment and the detection thresholds, suggesting that threshold seems to be unaffected regardless of the felt embodiment. This is again supported by a 7 times higher likelihood for the absence of a correlation between embodiment and threshold. Thus, we conclude that in our study, the sense of embodiment did not have a practically relevant effect on the hand redirection thresholds. And why did I say practically relevant effect? Well, we only tested offsets that would allow designers to create tangible effects, for example, triggering haptic sensations. However, it could be that there are much smaller effects, but these would merely be of theoretical nature. We also only tested horizontal redirection to the right for a participant reachable area. So whether our results generalize to other types of redirection or beyond reach interactions is unclear at this point. But this opens up an interesting question. How can we render beyond reach interactions that aim to remain unnoticeable to users? So do we visually crow the forearm, or do we dislocate the shoulder or the elbow? That's an interesting question for future work. To summarize, our results confirm that more complete avatars lead to an increase in embodiment, and our Bayesian analysis provides first evidence for the absence of a practically relevant effect on detectability of hand redirection. We conclude that designers can likely continue to use existing hand-based illusion techniques and their perceptual thresholds regardless of the avatar representation. Thank you very much for your attention. I hope you have an amazing conference. See you.